Third, generally 10th class students have problem in this, which is series combination and which is parallel combination. See what happens, the words in day-to-day life and the words in physics, they have different meaning. So sometimes we carry the meaning of the words from day-to-day life to physics, and there we face problem because in physics the meaning may be something else. So here when I am talking of series and parallel, so when I am talking of series and parallel connection, what do we mean in physics? So in series connection, the same current flows through all the resistors. Let's say these are the resistors, and let's say they are connected in such a way that the same current has to flow through each of them. The current, all the three resistors come in the same path. There is no branching. So whatever current enters here, it comes out from R1 and it enters R2. It comes out from R2 and it enters R3. The same current has to flow through all of them. Then the resistors are said to be in series. Now it doesn't matter whether they are in a straight line or whether they are not in a straight line. I am talking of series combination. So the criteria is not to see that whether they are in a straight line or whether they are not in a straight line. It is to see that whether the same current is flowing through all of them. Sometimes they may not be in a straight line like this. Sometimes the resistors may be like this. Sometimes the resistors may be like this. Look at this. Look at the connection. This is R1, this is R2, this is R3. These three resistors, they are in series. Because you see the current, once it flows to R1, it has to flow through R2 and then it has to flow through R3. All three of them are along the same path. There is no branching, right? So that's the criteria. It's not that these three straight lines, they are parallel lines, so the resistors are in parallel. No, that's not the criteria. In day-to-day life, we may have the meaning of series and parallel like that. But here, series means the same current flows, not how they are placed. Okay, now coming to parallel. Parallel connection means if the same potential difference exists between all the resistors. For example, let's say here is a resistor. Here is a resistor. Here is another resistor. Here is another resistor. Now let's say all three of them are connected to the same point. All three of them are connected to the same point, A and B. So the same potential difference exists between A and B. Then we will tell that all the three resistors, they are in parallel. So here the current gets divided and then again it gets merged here. And again it gets merged here. So the connection has to be in this way, right? That the current gets divided and again it merges. Now the problem with students is that they only see this part. Wherever they see branching, they think they are in parallel. No. Again, all the three branches has to merge. Then only we will call them as parallel. And we don't have to see how they are connected. So sometimes the resistors may be connected in this way. First resistor, second resistor, third resistor. R1, R2, R3. They may be connected in this way. And like this. This is A, this is B. It seems like all three of them are in a straight line. We feel tempted to say that they are in series connection. But no, they are not in series connection. They are in parallel connection. You see every resistor, this resistor, one end connected to A, the other end connected to B. You see resistor R2, one end connected to A, the other end connected to B. You see resistor R3, one end connected to A and the other end connected to B. So if you redraw this, this becomes this. R1, R2 and R3. We have three resistors and all three of them are connected between 2 points A and B. So they are in parallel. The same potential difference exists between them. So what are the misconceptions here? So generally students think that series means resistors has to be in this line, in a straight line, and parallel means resistors have to be in parallel. No, that's not the criteria. It doesn't matter how they look. Looks are deceptive. Don't go by looks. You see how they are connected, how the current flows, right? Series means the same current has to flow through all of them. This is series, this is also series. Although one may feel tempted to say that this is parallel. No, it's not about how it looks like, it is about how the current flows. Similarly, parallel means the same potential difference exists between all three of them. It's not about how they look like. One may feel tempted to tell that this is series. All the three resistors are in series, are in a straight line. But no, this is not series. This is parallel combination. This is parallel combination. This is parallel combination. Students mistakenly think that this is series and this is parallel. I hope I am clear about series and parallel combination. I will take one more example. Let's say here is a resistor. Here is another resistor. Here is another resistor, and here is another resistor. Let me name them. This is R1, this is R2, this is R3, and this is R4. Let's say here is R2. Here is R2. Now, let's find out which resistors are in series and which are in parallel. R1, R2, are they series? No, they are not in series. Although someone may feel tempted to tell that R1 and R2 are series. It seems like the current which comes to R1 goes like this. They are in a straight line. No, here there is branching. Whatever current comes through R1 gets divided here. Part of it goes to R2 and part of it goes to the other branch containing R3 and R4. So R1 and R2, they are not in series. Acha, what about R2 and R3? Are they parallel? No, R2 and R3, they are not parallel. Because you see R2 and R3, although these two ends it's connected to the same point, the other two ends they are not connected to the same point. The other end of R3 is here, the other end of R2 is here. They are not connected. Here there is R4. So this is another temptation to tell R2 and R3 are in parallel. R2 and R3, they are not in parallel. We don't have to look at only one side. We have to look at the other side also. Okay, R2 and R3, on one side they are connected together, but on the other side, R2 and R3, are they connected? No, R3 is connected here, R4, right? And many times, what do students think? They think that if two resistors are not in series, that means they are in parallel. If two resistors are not in parallel, that means they are in series. It's not like that. You can have resistors which are Now you can have two resistors which are neither in series nor in parallel. Like here, R1 and R2, they are neither in series nor in parallel. R2 and R3, they are neither in series nor in parallel. What about R3, R4? Yes, R3 and R4, they are in series. The same current which flows through R3 has to flow through R4. They are in series. What about this branch and this branch R2? Yes, they are in parallel. Here the current gets divided, flows through these two branches and then again merges here. So this combination R3, R4 and R2, these two branches, they are in parallel. Hope I am clear.